Chapter 11 is on pricing strategies for firms that have market power. We talk a lot about perfect competition, and that's kind of boring because the price is set by the market. But what if you have some degree of market power? That's when this chapter kicks in, and we can have a little fun with a little power. We can use some simple elasticity-based formulas to determine the profit maximizing prices where a business enjoys some market power. Secondly, formulate some pricing strategies that permit firms to extract additional surplus from customers based on certain conditions. The first is price discrimination of a few different varieties. Next, two-part pricing, followed by block pricing, and then commodity bundling. The next group would be looking at pricing strategies that enhance profit based on special cost and demand structures, where we could take advantage of those. And we'll look at peak load pricing, cross subsidies, and transfer pricing. And finally, we'll look at profits in markets where there's intense price competition. The techniques there would be price matching guarantees, randomized pricing, and brand loyalty programs. And this particular chapter is going to resonate with many of you because we as consumers have faced all of these at one point or another. First, let's look at a review of basic profit maximization. Let's say you have a firm with market power and you're facing a downward sloping demand. The implication is there's a trade-off with high number of units at low price or a few units at a high price. So our objective is to set the quantity that equates marginal revenue and marginal costs. Therefore, that charges the maximum price the consumer will pay at that level of output. So here's an example. The inverse demand curve is given by price equals 10 minus 2Q. That's a very common looking formula we've seen throughout this course. And the cost function is 2Q. In other words, it's a constant marginal cost of 2 per unit. What is the profit maximizing level of output and price? All right, let's solve this problem. First, we know that the maximum profit is achieved where MR equals MC. In this case, we know the marginal revenue is equal to 10 minus 4Q, and that's essentially the demand curve with the double slope. So where price equals 10 minus 2Q, the marginal revenue is 10 minus 4Q, double the slope. The marginal cost was given to us as 2Q. If we take the derivative, we get 2. So the marginal cost is 2. And if we equate these, we get this formula, 10 minus 4Q equals 2. And if we solve for Q, we know it's 2. And at quantity of 2, the price becomes 10 minus 2 times 2, or 6. So that's the answer to this first one for what would happen if you had one quantity at one price, right? That's important to know because we're going to do some things a little fancier than that in this chapter. What if we don't have a handy formula for our marginal revenue and marginal cost? We have a way to use a crude estimate based on the marginal cost, which you should know, and secondly, the price elasticity of demand, since this might be representative in an industry, or you may be able to derive it through some testing. So with this, we have this function where MC equals P times 1 plus the elasticity of the firm divided by elasticity of the firm, where marginal revenue equals P times same factor, 1 plus elasticity of the firm divided by elasticity of the firm. And then we would set the price such that P equals elasticity of the firm divided by 1 plus the elasticity of the firm times marginal cost. Here's an example of how we might use this. A manager in a convenience store competes in a monopolistically competitive market and buys cola from a supplier at $1.25 per liter. The manager thinks that since there are several supermarkets nearby, the demand for cola sold is slightly more elastic than the representative food store. Specifically, the elasticity of demand for cola sold at her store is -4. What price should the manager charge for a liter of cola under these circumstances? All right, let's use our new friend in this calculation. So in red, we have the formula we just saw, and let's apply it to the back circumstances. First, we know that the marginal cost of the cola is $1.25, and we know the market factor is 4 over 1 minus 4, which is 4/3. Therefore, the profit maximizing pricing rule has the price equal to 4 divided by 3 times 1.25 equals $1.67 per liter of cola. So let's look at what the pricing rule would be for a Conoa oligopoly. Let's assume that the industry has N firms and that they all have identical cost structures and have similar products. The simple profit maximizing formula for the Carnot equilibrium is price equals N times the elasticity for the market divided by 1 plus the N times the elasticity of the market times MC, where EM is the market elasticity of demand.